This video is a continuation of how to graph an inequality that contains two variables. Today though we're looking at other functions other than linear. So my first example is a basic quadratic equation. So again, the first thing you should do is graph this, and I would graph it as an equal sign and not worry about the inequality. So if I was going to graph y equals x squared, what you could do is make a table if you're unsure. So I'm just going to put in numbers from -3 to +3 as an example. So remember, when you plug these in for the variable, they're assumed to be in parentheses. So -3 squared is 9, -2 squared is 4, etc. So then when I graph this, -3, 9, -2, 4, -1, 1, 0, 0, and then with symmetry, this will repeat itself going this way. And you can see how I'll have a parabola here that's forming. Now, one thing I want to point out to you, like in the last lesson, this has a greater than symbol. There's no equal sign. So this should be a dashed line when I fill in my parabola here. So that means none of the coordinate points on this dashed parabola would be a solution. Now I have to decide how I'm going to shade it. So I want to choose a coordinate point. And because 0, 0 is on my dashed line, I can't use that. So I'm going to choose a point over here. I'm going to choose this coordinate point, 5, 3. I'm pointing by 3s here, so 5, 3. So if I put in 5 for x, that would be 5 squared, and then the 3 for y. So that would be 3, sorry about that, is greater than 25, which is clearly not true. And when I put that in there and it doesn't work, that means nothing on this side of the parabola would work. So I'm going to choose a coordinate point that's definitely on the inside. And if you look at 2, 12, that's a coordinate point that's definitely inside the parabola. So if I put in 2 for the x, so 2 squared, and I put in 12 for the y, well, 2 squared is 4, and 12 is definitely greater than 4, so I would definitely shade everything inside this parabola. Now, as it keeps on going this way, everything on the inside, all these coordinate points would be solutions to this inequality y is greater than x squared. For my next example, this is a absolute value equation. And again, this time you see that it has a less than or equal sign. So when I make my absolute value, which we know is a V shape, it should be a solid line. Again, you could plug in some numbers, and to make this, I'm just going to start at +3. If I put in 3 for x, I would get 1 for y. If I put in 2, I'm going to get 0. If I put in 1, 1 minus 2 is -1, absolute value would be 1, and you can start seeing it starting to go back up. If I put in 4, I would get 2. If I put in 0, I get 2. And this V shape is starting to come together. If I put in 5, I would be at 3. If I put in -1, I would be at 3. And again, because it has a equal sign in it, I'm going to go ahead and make these a solid line. A solid line. So there's my absolute value graph. Now I just have to decide which way I'm going to shade it. So this time I can use the origin because it's definitely over here. When I put in 0 for the y and 0 for the x, 0 minus 2 is -2, and the absolute value is 2. And 2 is definitely bigger than 0, and 0 is less than or equal to 2, so it does work. So that means I would shade everything on this side of the absolute value graph. The last example I'm going to give you is we were talking about exponential growth and decay quite a bit this year. So this equation is y is greater than 5 times 2 to the x. Now if I put in coordinate points, if I just want to put like in 0, to the 0, anything to the 0 power is 1 times 5 is 5. So I'm going to start at 0, 5 would be a dot. If I put in 1 for x, 2 to the first power is 2 times 5 is 10. If I put in 2, 2 squared is 4 times 5 is 20. And you can start seeing a pattern. I keep on doubling it, obviously. That's why it's 2 to the x power. So this would have to be 40. And then when I put in 4, I'm going to be at 80. So the exponential grows really fast. And because there is no equal sign, this is going to have to be a dashed exponential growth. Now, remember, the graph approaches but will never quite get to 0. That's called the asymptote line. So this will get really close but never quite touch the x-axis. So then, as the other ones, I have to decide which way I want to shade it. This time I'm going to go ahead and choose the coordinate point right here. I'm going to choose 5, 10. So I'm going to put in 5 for x. So I have 2 to the 5th power times 5. And then for y, I'm going to put in 10. And I don't even have to do the math because 2 to the 5th power times 5 is going to be way bigger than 10. So 10 can't be bigger than that value. So this point doesn't work. So I'm not going to shade on this side at all. If I choose a coordinate point over here, let's just shade. I'm going to choose this one right here, which is at 0, 30. So if I put in 0 for x, that would be 2 to the 0 power, which is 1, times 5 is 5. And I put in 30 for y. And 30 is definitely bigger than 5. So that coordinate point does work. So I would shade everything on this side of the line would be a solution. All these coordinate points in this area. And again, this goes on forever, never really close to 0. So it's all the stuff in this area would be solution. So again, it's like any other graph we have done. It's just with an inequality, you have to decide whether it's a dashed or a solid line. And again, choose a coordinate point to test on which solutions do make it true. And if it does, that's which area you will shade.